now we're ready to take our temperature readings. You can use regular thermometers here. I use my electronics, but I could take a thermometer and stick it in my ductwork right here. I could take and stick, I find little holes. Sometimes I have to drill a hole. I can stick a thermometer in there to get my return air temperature. In this case, there's a nice piece of metal here that at one time there was some ductwork tied to this. Maybe a humidifier, I'm not sure. Anyhow, I just put my probe in there and I'll get my temperature reading using my combustion analyzer with that one. I'll get my temperature reading using my multimeter with this one. I already turned the thermostat upstairs, so all I got to do is turn the power on. And what we're going to watch for is the fan on temperature. So this thing will kick on here, and we'll get the fan on temperature at 5 minutes. We're going to be looking for our heat rise temperature, and then I have to go turn the thermostat down, and we want to get our fan off temperature. Those are the three temperatures we look for. Okay, we got our furnace running. You can actually see the temperature starting to climb here, but the fan has not kicked on yet. We're waiting for a fan kick on temp. So the heat exchanger will heat up, gets to a certain temperature, then it turns the fan on. We don't want to turn the fan on instantly, otherwise we blow cold air. So we're at 112 degrees right now. I like to use these probes because I can drop them down into the duct work. It's kind of nice. I get a little more accurate temperatures. We like to see a fan on temperature from anywhere from 120 to 140 would be nice. Try not to exceed 160. So we got that fan came on at about 140, and I don't know, I can tell after putting that, moving that filter, this thing's running a lot quieter, just from the filter not running up against the pulleys. And now our temperature's dropping because we're starting to move heat into the house. Dropped a little bit, now it's coming back up as everything stabilizes. We need this to run for 5 minutes to get to a steady state heat rise. So we'll let that run. This takes a little while. I usually time it with my watch. I got a pretty good idea from there. I can see my return air temperature. While I'm waiting, a lot of times what I'll do is I will check for gas leaks on the piping around here, and I have a sniffer for combustible products. I already have it adjusted. I'll readjust it here. And then I can go around and get a reading from my different fittings to see if I have any gas leaks that need to be taken care of. I even check the old gas lines. Anything that I can see, it's not hard for me to check them with this, and I can get a pretty good idea. Looks like we're pretty good. I'll even check inside the furnace a little bit. Sometimes you can have a cracked gas valve. And looks like we're good there. Okay, we're at our 5 minute mark. Looks like we have about 235 degrees, 230 degrees is our air temperature. We'll call it 230. I That's a really high heat rise, and it's more than likely caused by the plugged filter causing that high heat rise. So 230 there, 75 here. That gives us 155 degree heat rise. We like to see 30 to 50 degree heat rise, no more than 80. And what this furnace will do, in fact it just did it, it cycles on high limit because we don't have enough airflow. It gets so hot that it turns the gas off, and which is right about 230 degrees. The nice thing about that is when it cycled off at that, I know that the high limit on this works, and it's around 230 degrees that this thing shuts the gas off because it's getting too hot, and keeps the fan moving, the air moving with the fan. So really, by changing this filter, we're going to be able to have a pretty good effect on the efficiency of this furnace when it's all said and done. We'll put a new filter in there, we'll get a new heat rise, and it'll drop dramatically, and this thing will run much more efficiently. So we got a little work to do, change that filter, and then we'll get the fan off temperature at that point in time. All right, so we're checking the carbon monoxide. This is a natural draft furnace, so and this is the draft hood, so we have to stick our probe to check for CO up into each of the burner exhaust ports. There's on this one there's 4 burners, so there's going to be 4 exhaust ports for me to check. So I'll stick my probe up into the first one here, and I get my you see my oxygen starting to drop, and it's starting to read my parts per million of carbon monoxide. So this thing, I always want to be under 100 parts per million. Usually on a good running furnace, you'll be well below that. We'll wait till it stabilizes, then we'll move to the next one. Looks like we have about 34 parts per million. That's a good number. We'll go to the next one. For our agency, everything has to be under 100 parts per million. If I were to check this measurement up here, then whatever parts per million I would have would be diluted by my air from here, and so this gives me the most accurate before dilution. Okay, so this is a little higher. I'm still below 100, dropping. It went up and then it dropped back down, but we're in the 30% or 30 parts per million. Okay, I'm going to go to the next one. Okay, so I'm over 100 parts per million here. So this burner right here, I have an issue. This burner is not, it definitely has a problem. Very high, considering 100 is as high as we go. It seems to be jumping around quite a bit. I don't know. So let me get it in there real good. Still above, definitely above. Some work needs to be done on that one. Okay, I'm going to go to the next one. Okay, I'm getting very, very massive amounts of carbon monoxide on this one. I definitely have a very bad burn on here. Okay. Yeah, that's way, whoa, high. Based on those high CO readings, I just want to get a room reading to see what I'm being exposed to as I work. And when I first turned this on, I was reading 0, but I'm just going to confirm it. I turned it on outside, brought it in. It zeroed out outside, so I brought it in and it was 0. So we do have a little bit, but it's dropping off. It's filtering through the unit right now. Often I'll use some smoke to make sure that, just to get a visual of the draft. I can use my combustion analyzer to get draft too, but it just is a real quick method for me to see if my unit is drafting. And then I'll also go over to the water heater and make sure that it is drafting, and I can see that it's pulling up combustion gases or any gases that would be around here. It's not backdrafting, and that's the key, especially when I have that high of CO. Okay, we're going to use our combustion analyzer to get our draft reading and see how much draft we have. What we have, let's see here. Okay, right now we're getting 0.03 inches, 0.02 inches of water column of draft. So we do have a negative draft. Right now we have all the doors that could be shut to this area that we're working in shut. We have all the fans running. We're creating the worst case CAS, combustion air zone, with all the windows shut, the fans running, and we still have good draft. Based on the outside air temperature and this reading here, we're within range of where we're supposed to be. The other thing is with that high CO we were reading, I want to get just a reading of what our diluted air is, as far as how many parts per million we're getting. Looks like it's 24 parts per million here. Air free is 55 parts per million. It's going up though. We'll just kind of watch it and see. So basically what this is telling me is there's enough air diluting through here to those two burners that were kicking out a lot of parts per million. We have enough oxygen mixing in to dilute the parts per million way down. Okay, this is another method of measuring the draft in the flue. This is a draft right gauge. And what you do is there's a hole on the back. You level this thing out. Stick your finger over the hole, and then you stick it into the hole for I'm reading draft. Okay, I need to make sure I get it leveled out. Stick it in the hole, let my finger off, and I'm getting a draft of minus 0.02 inches of water column. Okay, out, and then I use my chart here. I have a chart here that tells me I'm about 60 degrees outside, so between 30 and 80, so I'm in that range. I need to have greater than minus 0.01 inches of water column, H2O, and I have minus 0.02, so I have adequate draft for this temperature. It varies with temperature. The threshold varies with temperature. One of the things I could kind of hear on this furnace is it has I'm pretty sure it has some flame rollout. So we'll take the cover off here. I will go ahead and start it, and we'll see if this fills up with flames when this thing does, when it first starts. Okay, so there's a little bit of flame rollout on that, not too much, but there is a little bit. These older furnaces don't have any safety devices. The newer furnaces would have like a heat sensor right here and maybe a heat sensor right here, and if they get too hot, they shut the gas off. And flame rollout would if it was substantial, would cause that switch to open and shut the gas off. So there's some safeties these older furnaces don't have that we really want to make sure that we don't have a lot of flame rollout on these. Okay, we have the the flames are burning. What we're looking for here is right when the fan comes on, we want to see if there's any interference. That's a sign of a cracked heat exchanger. So right when the fan comes on, we're looking for those flames to dance a little bit. That's a sign that we're looking for. Okay, those flames look pretty steady. That fan came on. They're pretty steady. That is one indicator that we don't have a cracked heat exchanger. Okay, right now I've turned the gas off, and all I'm trying to find out is what my fan off temperature is. So the fan's running, my gas is off, and there'll be a certain temperature. We want to see that fan come off 85 to 95 degrees, and at the same time this is going to cool this furnace down so that I can pull the blower motor. I'm really when I pull that blower motor, I'm going to be looking up into the heat exchanger. I have a sneaky suspicion that the heat exchanger may have a crack in it based on the high parts per million I was getting. So I'm really going to spend a lot of time looking to see if there's a crack in this thing. But we'll get this fan off temperature here first. So the temperature's dropping. So that fan's pulling out the remainder of the heat out of the heat exchanger, delivering it to the house. No sense in leaving that heat energy sitting in the furnace. And there we go, 90, 93 and a half, 94 degrees. That fan turned off.